Hello and welcome to class 7 of 9 of my Oracle SQL for Beginners course. My name's Ken Marr. You can reach me with queries here, oracle@kenmar.fastmail.net. This is class 7, and if we jump to the contents, we're looking at functions today. Page 127. So this looks at the most commonly used functions. Number, null, date functions, commonly used conversion and character functions. Number, null and date functions, aggregate functions such as count, average, minimum, maximum. Group by and having used with aggregate functions, and roll up and cube used with group by. So we start with simple character functions. Now in previous classes we've seen things like upper and lower, init cap. You see these here actually. If I select that and I click there, that gives you upper, lowercase and init cap, which is first character in uppercase. It doesn't work that well actually. There, it's gone lower, upper, and it's lower again I think. Where's init cap? There's init cap. It doesn't seem to cycle that well, but it works, those three. We haven't seen substring and instring. Here's an example of a couple of these that we saw earlier. Here we're using init cap and concatenating first name and last name from the employee table with a double pipe, space in between, putting the first character of each word in uppercase, and then give it an alias full name, and we get that. Well, we do if we connect. You can try the examples here and the exercises if you want to. Now let's move on and look at distinct. So they're just simple character functions. Distinct and substring. When you do a select from a table, like just the credit column from supplier, what you're actually implying is that you want all that column. You can put all, but people don't because it's the default. As an option, you can remove the duplicates. There are duplicates values there of A, B, C with distinct or unique, which gives you the distinct or unique values. There's a simple use of this. When we looked at selecting today's date, sysdate there, and also getting day, month, year from that, and the time from that. If you do it from a table like Sailord, rather than dual, you get a lot of rows. People use dual to select system variables like this because dual's only got one row, so you're going to get one row back. With Sailord, which has got 11 rows, you're going to get 11 rows back, but you can stop that by using distinct. Whoops, not like that, like that. Everybody notice, you notice how it changes colour? If it's misspelled, it's not in blue. Get it right, it goes blue. There's my one row. Put the notes back actually, as they were before I started. Whoops. So I wasn't going to change this file. Now you use distinct with other things like substring. Substring, most programming languages have a structuring function, allows you to pull part of a string out of the string I suppose, and you give it parameters such as a column name, a start position and number of characters to return. So here are postcode and the first three characters of postcode. By substringing postcode, saying 1,3, giving it a heading. And if we just select the individual first three characters of postcode, we get duplicate values. If you want rid of them, you can use distinct. Like that. Then we get individual values for Y01. What we're leading up to actually is doing a count of how many there are for each of those. But we need to do something else first. You look at the exercise, there, products. How many distinct product lines have we got? It says a product line is the first two characters of product ID. So use substring to get the first two characters and get a distinct list of product IDs. Now, as well as substring, you've got something else that's very useful, which is called instring. Instring searches within its input, which can be a column or some text, for a particular character. So for instance, here we're looking for a space, and it returns an integer. So it's the 7th character, the 6th character, the 2nd, the 7th again, the 8th, like that. You can look for multiple characters. If they're not there, you get a 0. So AR doesn't exist in those, but it exists there as the 13th and 14th characters. Now if you look for a particular character like A, it counts from the left. It's the 6th character, the 2nd, it's case sensitive, so it's not there. There's one there, it's the 6th. You can get it to search and find the last character, that's an A, but it counts from the left. For instance, it will find that A and count from the left if you use -1. So that A is column 13, counted from the left. Now we can use this well. Where the postcode just now, you probably noticed, or you may not have, some of these postcodes are 4 characters. LS12, WC12, WC14. So if you try and find the area code by the first part of the postcode, which we use here, so that's York, that's Bath, you can't just take 3 characters, you want 4 characters there. And the way you do that is you use instring. What you do is you pass instring as a parameter to substring. So here we are substringing the postcode still, starting at character 1, but stopping at the first space. And that will return an integer value, so it'll be 4, 4, 4, 5, 4, 5, 5, 4, 4, like that. And we'll get back that. I've concatenated an asterisk there, so you can see what we get back. So what we've got here is the first 3 or 4 characters followed by a space concatenated with an asterisk. If you want rid of the space, what you do is you take away a character. Like that. So substring postcode starting at 1, find the space, go back a character, -1, concatenate the asterisk so you can see it. There you go. Now this sort of thing is often used with tables that contain names. Now we've got 2 tables with names in. The first one we've used in employee. To find the full name, we've been concatenating together the first name. Go on. There we go. First name and last name. 2 different fields. Now some tables have the name as 1 field. And that's true of the member table. Whereas the name is just 1 field. However, suppose you want to sort members by surname. You need to find just the surname. So that's the exercise here. List the member ID and name for the member table. There you go. Then list member ID and name sorted by surname. And you do that with substring. bear in mind if the last parameter is left blank, it defaults to the length of the column. So your substring will start at that space plus 1 and go to the end. That's a treat for you. Okay, back here. Put things back as they were again. There we go. And move on and look at number functions. Now we've seen several of these. We've seen round for rounding, ceil and floor for going up and down to the nearest integer above and below. Trunc, we truncated dates to remove the decimal. You can truncate a decimal number, it removes the decimal instead of rounding it. So it's a bit like floor, I suppose. What we haven't seen is mod there. Now here's some examples of mod. This one, mod the salary divided by 12. What mod gives you is the remainder. So if you run that query, what you get, trunc the salary over 12 will give you the salary per month with no decimal place because it's truncated it. Mod will give you the remainder. So there's 8 remaining. So these ones divide exactly where the remainder is 0, and the others give you the remainder of the salary. I'm not sure what happens if I make that floor. You get the same thing. I think you do actually. I'm sure trunk and floor have different uses, but they're the same in that instance. Here's another example which isn't in the notes that somebody came up with. Actually, I'm sorry, it is in the notes, I put it there. This query returns only rows with an even employee ID, so what you're getting is every other employee. And you might do that if you're trying to extract the data. So for instance, you want every third employee, divide it by 3 using mod. If the remainder is 0, you get every third employee, like that. Someone came on the course and asked about that. It's quite neat, that. I like that. NVL we've seen, but we haven't seen NVL2, nullif or coalesce. These are all null functions. So the first one, if you remember NVL, we did it by looking at the supplier table, and it was printing null, which is what developer prints by default if it's a null value. We use NVL to put not known if county was null, otherwise print the county, like that. And we got not null. Now what you can do with this, which is really useful, is use it with numeric values. For instance, here we're trying to find the full name, there, that's full name, their salary, their bonus, and their salary plus bonus, which you could call their full salary, or total remuneration, I suppose. Now what happens is if any of these are null, it doesn't work. So for instance, if they have a salary and no bonus, you add them together, you get null. If they have a bonus and no salary, you add them together, get null. If they're all null, he never gets paid, you get null. Now to stop it doing that, what you use is NVL. Here you say no, it's not there, is it? I beg your pardon. It's not there, I'm going to bike it in. What you do here, you say NVL, if salary is null, use 0. And here, do the same for bonus. NVL, if bonus is null, use 0. And then you get the right answer. So NVL can be used for that. See now, you get the salary, bonus, add 0 on instead, you get the right answer. He gets 0 because he's got nothing. They get the right answer as well. And there's an exercise there on that. Nested functions. You can nest functions one within the other, which we've already seen actually with substring and instring. But here's another example. Often, instead of printing 0 when a salary or bonus is null, you might want to print the word none, like this, there. Well, we've got bonus in uppercase there. That's better. It's prettier like that. Okay. Doesn't work. It says invalid number. The invalid number is none. Bonus is a number. So you have to put a number there, like 0. If you want to put none there, what you have to do is convert bonus to character. So it's the same as none. Same matching data type. And you can do that, if you remember, with to char, which converts things to character. Convert it to character and you can print none where there's no bonus. That's quite neat. I like that. Now there aren't any that's not going to work, that, is it? Tell you what, we'll go back where we were. Can't have no changes and then change things. These other functions are used with nulls. There's no exercises on them, to be honest. It's hard enough just thinking of an example. But here are some simple examples. Suppose you wanted to give someone a view based on the employee table, but you don't want them to see salaries. However, you want them to know whether people have got a salary or not. You can do that with NVL2. So in this example here, we're printing yes if bonus has got a value and no if bonus has got no value. And this one does the same thing, but it does it for salary as well. So, salary, yes or no? Yes, they've got a salary. No, because those are null. This one, bonus, yes or no? Yes, they've got a salary. No. Remember, there's a couple here where they haven't got a salary, and there's somebody who's got no and no there. It's like a sort of if statement, which is what null if is. Null if is like an if statement. What null if says, if I run it, it's easy to see because of the column heading I used. It prints null if they're equal, else it prints, hang on, the first. So they're the same, so it prints null because they're equal. They're different, so it prints the first. Prints the first, they're the same, so it prints null. They're the same, so it prints null. So it is an if statement. And this is as well, coalesce. Coalesce starts at the left and it prints the first non-null field, or it prints the last field as a default. So bonus plus salary. If it's non-null, it prints it. Non-null. It's null there, so it looks at salary. If salary is non-null, it prints it. Down here, salary is null, so it looks at bonus and prints bonus. And then if they're both null, prints -1. So it's the first non-null field, the two together, the salary, the bonus, or -1, like that. There aren't any exercises on that. It's a bit difficult to think of them. So let's move on and look at date functions. You've had too many functions. Here's some simple examples of date functions. You've got sysdate and systimestamp. Sysdate returns the date, just day, month, year. Systimestamp, day, month, year, hours, minutes, seconds with decimals. And actually I'm not Greenwich Mean Time, I'm British Standard Time, summertime here because it's an hour past, but it will show you your time zone. The other two there, next day and last day. Next day says, well, what's today? When's next Friday? Next Friday is the 24th. Today is the 21st, so next Friday is the 24th. And if you want to know when the last day of the month is, it's the 30th, because sometimes it's 31st, and in February it might be the 28th or 29th. That's what you use those two for. These ones we've seen, to date, to char, to trunk, used with dates to convert a date to character, to convert character to a date, to convert a date to character, and to truncate the date to remove the time. And then you can add and subtract dates. It does it on days. If you want to add and subtract months, you use add months, and you can find the difference between two dates with months between. There's a few other things here that came up in the course. Somebody asked, how do you give the first day of the month? Well, you just say to date. You want 01 and then to char sysdate, MMYY. Format that as day, month, year, and it will give you the first day of the month. You could do it last day of the month, I suppose, as well. Somebody asked, how do you find the first day of the month when someone was born? Well, the employee table has birthdays. To char the birthday, pick out the month of the year, concatenate it with 01, and you get the first day of the month they were born. Now if we move on and look at add months and months between, the reason you use add months is you can't reliably add 365 days. It might be the same as adding 12 months, but it might not, depending on leap years. If you do it for this year, they're the same. It's not a leap year. But if we use to date and pick the date 2012, then you'll find if we add on 365 days and add on 12 months, we get a difference because it was a leap year. So adding on 12 months adds on an extra day for the 29th of February. So it's more accurate to use add months than it is to use adding 365 days. This one is trying to add on 48 months as 4 times 365 days, and again you get different values because there's a leap year involved somewhere in there, because there's one every 4 years. So add months will include the leap year, adding the days won't. And if you want to subtract, there's no subtract months, use a negative. So if I take 365 days away from date order and use add months, I get that again you get different things because you're going back from 2013 into 2012, which was a leap year, so you get different dates. There is an exercise on this actually over the page here. Examine the employee table. Each employee has got a birth date. There. And this is display the name and age of each employee. So you take that away from using months between. Did I just do months between? I didn't do months between, did I? Sorry. Skip forward there. There's months between over the page. Months between here returns the months between two dates. So the order date on the sale order table. Now what you'll see, if you do it months between, you get multiple decimals. So you might want to round that up and retrieve the decimals. Don't put comma 2 there if you want no decimal places. So that's the number of months between today's date and the date it was ordered. Now to do that and get how old people are, find the number of months and divide it by 12. You might then have to use floor if you've got a decimal to take it down to below. If you round it, it will round up and they'll be too old. Think about it. It's in the exercise there. We've seen to char to date. You've also got to number. So there's an example of to char, which we've seen several times, converting dates to character. And this one, people often ask, when you run a query, I'll see it from there actually. Well, I suppose you can actually, if we run that, right? If you don't format a field, cost comes out like that as 20. That's just the cost column now. That's cost 1. You don't see the decimal places if they're zeros. If you want the decimal places, one way of doing it is use to char and the cost with a template. Now what the L does, it gives you a pound sign. If you want, I don't know why it's an L, if you want a dollar sign, put a dollar there. And then you get a dollar sign. To be honest, I don't think you need anything there. It looks better like that. And you could just put the dollar sign there in the heading. If it's in dollars, like that. But it's up to you how you want it to look. Sometimes users like to see a dollar sign or pound sign on every one. I've done the same thing with the margin there, 9,999.99, so you get the decimal places there. Which is nice. Okay, I'll get rid of that. Now we've gone back here, I think, to where we were. Yes. Aggregate functions, these are fun. The aggregate functions are a group including count, minimum, maximum, sum and average. And it says, note that these functions ignore null values in any column. And the simplest way to use these is put them in a query on their own. Although you can include round, don't put any other columns, just functions. So these are some simple examples. How many rows on the supplier table? 9. What you get back with these is one row, because there's nothing else in the select statement. There's the minimum cost, maximum cost, and average difference between the selling and the cross pass, which is the markup. And there's one which gives you the total value of all orders by summing quantity times sell off the two tables, product and sale line, and joining the two tables together. Actually, it's in the notes the other way around. It's a bit naughty. So let me change that. Just so it matches. There we go. Exercise there for you to try. Now, you can do a few other things with count. For instance, if you look at the supplier table, is there an exercise? Yeah, there's an exercise there on the employee table. If you look at the supplier table, then if you want to count how many suppliers there are, if you count supplier ID, as I did above, up there, it's never going to be null. It should be ignored because it's the primary key. As an alternative, you can put an asterisk in there. And the difference here, if you count address 1 and address 2, some of those have got null values, so you don't get the same numbers. So there are 9 rows on the table, 7 of them have an address 1, 6 of them have an address 2. And the other thing you can do with count is you can use unique or distinct in the brackets, and that returns unique or distinct values. So here we're counting how many rows are there on the sale line table with order ID, the primary key, so it's never null. So we get 23 rows, but if we count distinct order IDs, there are multiple values of the order ID, and there are only in fact 7, I think, different orders on that table. So that's what that does. If you wanted, you could give that a column alias. Give any of them column aliases actually. And there's another exercise there. You can try the same thing on the employees table. Now these come into their own when you add a group by clause. Go back to sale line. So order number 100 has got 2 rows. 101's got, I think, 8 rows. 103's got 1 row. 104's got 3 rows. So suppose you want to produce a report which says 101's got 2 rows. Sorry, 100's got 2 rows. 101's got 8 rows. You get the idea. 103's got 1 row. 104's got 3 rows. What you do is you count the rows within the column order ID. Now that fails because if you add anything to the select statement, columns other than aggregates, they have to go, same thing has to go in a group by. So to get it to work, you paste, well I copy and paste order ID, same thing there as is there. As a rule of thumb, it's very rare that they're different. And there's your count. 100's got 2, 101's got 8, 103's got 1, etc. And you can do a similar thing, what we did earlier, for order totals. We did that one just now. We found the total value of orders by summing quantity times cell. There's sum quantity times cell, but this time we've included the other 2 tables, supplier and sale order. So we're joining all the times together. Then we can pick up the supplier name and the order ID, and it gives you the total value of orders per supplier, because we're grouping by supplier name and order ID. That's in the select statement. Same thing there. Ordering by supplier name. And that's the total value of each order. Add that lot up and it will come to, or whatever we got when we ran that. There's an exercise there again on employees, average salary for male and female employees, and there's the average salary for both male and female employees grouped by gender within the manager code. There's the employee table, if you want to look at that. Now you can modify group by with various things, including roll up and cube, to get more rows. So let's have a look at the employee table. Here's the employee table, selecting manager, gender and the average salary from employee, group by manager and gender, and ordered by columns 1, 2. So what you get is female and male for each of the groups. Now I'm going to update the manager table here and set a manager for the manager who doesn't have a manager, if that makes sense. The guy at the top, Alan Brown, doesn't have a manager, but it does rather make the figures more difficult to understand. So what I usually do is update that for him. That will look different in that now he's manager 9. He's at the top. We've got figures for anything. Now what you can add here, first of all, is a roll-up modifier. And the easiest way to explain it is to show you what it does. If I change that group by to say group by roll-up, manager and gender, what you get effectively is more rows. So there's the query there. If we bring that up a bit, not that far. So what we've got now is female, male, which we had before, but we've got the total for, well, it's department 1, for manager 1, total for 2, 3, 4, 5, and 9. That's the total. He's the only one in there, so no females in there. And this is the average for everybody. And then if you cube it, you can get even more rows. So we take that one out and put the cube in and run it. Got 2 group bys in there. That was silly. How do I do that? There we go. It says you're only allowed one of those in a query block. So now we've got a few more rows. We've got, again, for each one, female, male and the total, all the way down to 9. And then as well as the total average, or the average for everybody, we've got the average for all females and the average for all males. So roll up and cube just give you more rows. There's no exercises on that. Clever, isn't it? Let's just set it back again. It's better. I don't want to mess up the sample file, so I hope to use it again. Having. Now there is another thing you can add if you're using group by, and that's a having clause. Now you might want to use this because you can't put a where clause like that. You're not allowed to say where the average salary is greater than the value. A group function is not allowed in a where clause. What you've got instead is a having clause, which is like a where clause for functions. Does the same thing. There. So you say having the average salary greater than that. In fact, you can put the having before the group by, but I always think it makes more sense if you read it this way and say select that group by having that greater than that. Of course, you can use MVL to get rid of the null values that appear when you're doing this, and also you can have a where clause if you want to say where manager is not null. That doesn't make sense actually, because we changed the manager, so it isn't not null, but you can add a where clause. No, that doesn't make sense. Take that out, I think. Right, so let's run this one and you'll see what I mean. This does a roll up again, but what you get now, oops, we push it up a bit, you get male and female for department 1, and then all, so that's the average for men, average for women, average for everybody within that department, for all the departments down to department 9, and then a grand total for everybody, the average for everyone. So you can, with judicious use of NVL, fill things into the report. And there's the full syntax. Well, you can add a few other things to a select statement. Stop there to have a cough. But basically the syntax is select your columns from your tables, comma separated, with aliases, joined together, group by whatever's in the first column, having a sum greater than, and order by goes last. You can group by functions. The postcode one we did earlier. Here's an example. Count supplier ID within postcode. So whatever goes there in the select statement, I copy and paste into the group by. I'm sure that's going to work. Is it going to work? Yes, it does work. I'm just wondering why I had postcode there. Because I've got P code there, so it's sorted them by P code. So you've got one for those. Do you remember there were 2 for Bath, 2 for York, and 1 for each of the others? Now, if you want to do an exercise on this, remember the product table we were talking about, and the fact that you could pull up the product ID as the first 2 characters of the product line, as the first 2 characters of the product ID. So the idea here is to find the average selling price grouped by product line. So what's the average price of a book, a disk drive, a keyboard, a laptop, where the average selling price is greater than £200. That's the exercise there. Okay, there are a few more functions. These are neat. These work on tables which have codes you want to decode, which is why it's called decode. So the first one looks at the supplier table. So here we are decoding the credit column, which, if you remember, contains A, B, C and D. If it's A, we're going to print good. If it's B, we're going to print fair. If it's C, we're going to print bad. Otherwise, we're going to print unknown. And that is the alias for the column heading. Oh, I see. That should be credit 1. Then it comes out like that. That's credit 1. Otherwise it makes it up for you if you haven't got one, which is what it did. So there we are. A, B, good, fair, good, good, fair, bad, bad, good, and unknown for D. I like these. You can do some neat things with this. For instance, if you decode credit in the same way and count how many there are for each, you can see how many there are for each. As long as you group by credit, which is the column that you've put in the select statement. Now the really neat one is to get it all on one line by counting each one. So decode credit to A as good and count it as good. And then you get 4, 2 and 2 going across, which I think is neat. A newer version of doing this, decode, you can use with what's called a case statement, which is like an if statement. A lot of languages support a case statement. Now this works in 2 ways. We're selecting from the same supplier table. We're doing the same thing but in a different way with a different function. You can case the credit and say when, or you can say case when credit. Now the first one, supplier and name, case credit when it's A, then you print good, fair or bad, else unknown, and ends there, the case ends there, and credit gives it a column heading. You get the same thing, good, fair and bad. This is a bit more flexible though. Suppose A and B were both good. Then you could have put good there, I suppose, as well. But another way of doing it is just say case when credit equals A or equals B, then good. These are like where clauses you can use in, like, between, is null, is not null, that sort of thing in there. And now you get good for A and B, and fair and good, and the unknown one. And these sort of things, a couple of exercises there using the employee table, These can be used to show age groups. I did this when I was working for a council who were very interested in how old people are because they had to manage pensions. So what you do here is, this is from the employee table, which contains birthdays. This is the solution to one of the previous exercises by the look of it. But obviously when you do this in a classroom, people do the exercises in the class. I hadn't thought of that. This gives you the last name, takes their birth date and displays it as day, month, year, and then says months between today and their birth date, divided by 12, but floored. So if it's 6.5, it goes down to 6. If they're, 60.5, they go down to 60. And then the case there does the same thing for their ages. And these are less than 18, less than or equal to 34, 44, 54, 64. Otherwise, they are over 65. And that gives you a list of ages. Actually, there are people over 65, yes. They get older as the course runs, because you're taking it away from today's date. In the next section, we'll look at counting how many there are within each age range, which is quite neat. You can do that as well with a subquery. That's another use of the case statement. And there's a few simple bits and pieces on the end here, just for completeness. You've got trim function, which trims things. By default, it trims spaces, so that will trim spaces off both ends of whatever you pass it. It could have been a column name, but here it's just text. Ltrim trims the left. Rtrim will trim the right. If you don't want to trim spaces, you can trim a character there. So that one, Ltrim, trims asterisks from the left. And this one trims leading asterisks from that. So you get example and then asterisks. And then the converse of trim, I suppose, is pad. You can pad things out. So you've got lpad. This pads out to the left with spaces to make it 30 characters long. This one's right pads to 30 characters, but it pads asterisks. This one pads to the left with asterisks. Now you have to watch with this is if you don't get the figures right, it truncates. So there you've said left pass with spaces, but because you've said 10, it's truncated it to 10 characters. Oh, I'm just wondering why my jewels are all there. I'm fussy about these things. Bit OCD, I suppose. There we go, it's better. And then lastly, you've got replace and length. Now, I'm sure there's more code in there, but I've taken it out. But you'll get the idea. Sorry, I was having to think there, because what's in the notes is not the same as what's on the screen. There's rather more on the screen. There's replace. You can use replace to replace things. So for instance, this is replacing spaces there with nothing. So it's like trim, it's doing left and right. There. Now a guy came in the course and he got this piece of code with commas in it, and what he needed to know was he had this string. So he had that string there. It was a very long string and he needed to know how many commas there were in a string. In fact, I found another example, which was this thing here. How many occurrences in there, say AEF, and this is looking at things like, use this for things like DNA strings. So what he did, he found the length of his string. Right, it's got 1, 2, 3, 4, 5 commas in it. So he took the length of the string, then he took the length of the string having replaced all the commas with nothing. Then he took one away from the other. So if you run that, like with most things, it makes more sense if you run it. There are 8 characters in there, but if you replace the commas with spaces, there are only 3 characters left. Therefore, if you take that length away from the other length, you get 5. So there are 5 commas. Now, another way of doing it, which saves you retyping this same thing 4 times, which is wasteful and prone to errors, is to use an SQL plus command called variable, which creates you a variable. So what you say is variable bchar, which is just a made up name, it's going to be varchar2, and then you exec bchar equals, give it a value, and then print it. And you run that as a script. So there's bchar. Now you use bchar, the same sort of thing. You say the length of bchar, replace the commas in bchar, take one away from the other, and you come back with the same thing. That's my fault. You can't highlight it and run it as a query as I just did. You have to run it as a script. So in this there are 49 characters, 19 of them are not commas, so there are 30 commas. And then of course he did a similar thing like this, but this is how you do it up to version 11G. Version 11G introduced regexp underscore count, which is a regular expression. Remember, we saw some regular expressions, we didn't look at this one. This is from 11G onwards. So there you just say there's bchar, count how many commas there are. It's dead easy. Sorry, I did it again. You have to run that as a script, pick up the variable. Well, there are 30 commas. And this one tells you how many occurrences of AEF there are in bchar. God, I've done it again. Sorry. A mess of this, isn't it? I want to go there. No, I want to go there. That's better. There are 18. You can count them if you like, but I'm sure it's right. Of course, if you wanted to do that previous to, like in 10G, you simply selected it, having defined your variable vchar, and set it. God, I've done it again. What's the matter with me? I'm not used to running the script button. There. There are 18 occurrences of AEF. It's always nice to have useful functions, and you know, if you ever had to count how many commas or AEFs there were in a string, that's the way to do it, with replace and then or regexp. There's a grouping clause as well, which just shows you whether null values have been used to calculate values in some of the queries in the cube or roll-up queries we've done, but I'm not going to go into that. And that brings us to subqueries and union. Okay, so the next class is subqueries and union. If I just go back to the beginning to see what's left, and go to 7. Right, subqueries and union, which I think I joined with advanced queries to make class 8. And then SQL plus and export and import I will do as class 9. So that's the end for today. It's the end of class 7. Thank you very much again, and goodbye.